right, so any questions on that one? All right. I'll leave that up there for a little bit. All right. Okay, so now we're going to go into inverse trig functions. And their graphs. Okay, so quick review on inverse functions. An inverse function only exists if a function is one-to-one, which means it passes the horizontal line test. And we'll do a quick review of that. So an inverse function only exists if the function is one-to-one. That means each x has a y, one y, and each y has one x. So if we had let's say A, B, C, and 1, 2, 3. This is your input. This is your output, which is just a fancy way of saying your x and your f of x. Okay. So we know this is a function because every x has one y. And let's say if we draw it again, one, two, three. If we go back the other way, we know that this is your input, or your x, your f of x. But this time, our y is equal to f of x, but since we're going the other way, we're showing that the inverse exists because each y has one x. So each x has one y, each y has one x, so you know they're both one-to-one. And each y has one x. Okay. Now, if you had A is 1, B is 2, and C was 1, then it wouldn't be one-to-one. They're only allowed to have one of each. Okay. Or if you wanted to do it graphically, it would have to pass the horizontal line test, which means that if you draw a horizontal line, it can only cross that graph one time. Any questions on that so far? Okay, so we're now going to apply this, but to our trig functions. All right, leave that up for a few more seconds. right. Okay, so we're going to start off with inverse of sine. Okay, so let's say we start with a drawing of how sine would look. Okay, so we know the sine wave kind of looks like that, and it looks the same if you go in the other direction, but not nearly as messed up looking or warped. Okay, so you have your x, you have your y. This is your sine. Okay, so we can see there to fail the horizontal line test instantly. If we draw a horizontal line, it will cross in more than one spot. So what we're going to do is okay, since we know, let's say this goes from negative pi over 2 to negative pi, okay, and this is our 0 there, which don't really have to mark it. Okay, so in order to pass the horizontal line test, we're just going to take it from negative pi to pi. Okay, so out of that entire graph, we're just going to worry about that one section. Kind of clean that up just a smidgen. Okay, so just if we cut just that one section, kind of looks like that. From pi over 2 to negative pi over 2. And we know it's going to go up to 1 and down to negative 1, which we might as well go ahead and mark it over here too, between 1 and negative 1. Okay, so really this is our y equals sine of x, where your domain, which is just all possible x values, is from negative pi over 2 to pi over 2. And your range, which is just all possible y values, can only go between negative 1 and 1. Okay, so remember, this is your x, this is your y. Now, if you remember the steps for an inverse, you interchange your x and y, and you solve for solve for y. So that means your y equals sine of x. Once we interchange your x and y, that gives us x equals sine of y. So now we have to solve for y. If you remember with the inverse of a function cancels it out. So what we're going to do is we're going to apply sine inverse to both sides. Okay, so that gives us sine inverse of x equals sine inverse of sine of y. Okay, so we just applied sine inverse to this side and sine inverse to that side. Okay, but we know the inverse and sine will cancel each other out. So we know that y can equal sine inverse of x. Okay, but once we interchange the x and y, for the inverse, we now have a domain of negative 1 to 1. Because remember, we switched our x and y's. So what was once the range is now the domain. And what was once the domain becomes the range. And your range is negative pi over 2 to pi over 2. Okay. So to get the graph of sine inverse, go ahead and redraw that. X and your y. Remember, we're going to change the x and y. So your x is now up here. So that goes between -1 and 1. And your y is now here, which is between negative pi over 2 and pi over 2. So you have pi over 2, negative pi over 2. And that graph is interchanged also, so it looks kind of like that. And this is your sine inverse of x. Okay. Remember, you have your domain of -1 to 1 and your range of negative pi over 2 to pi over 2. All right, and it also has the cancellation properties. Sine of sine inverse of x equals x for x between -1 and 1. Okay. But if you did switch them over, sine inverse sine of x, I guess you could use y there, but they usually stay with x, equals x for negative pi over 2 x less than or equal to pi over 2. But in most cases, you'll see that as y since they're talking about your range. But for overall, they usually try to stick with x. Clean that x up a little bit. All right, so any questions on that one? All right, I'll leave that up there for a little. Yeah, gotta make sure I point that out. Right. Okay. Okay, now quick reminder. Okay, the same way f inverse of x does not equal 1 over f of x. That's just a notation. It doesn't mean the function raised to the power of -1. Okay, so f inverse of x is just a notation for the inverse. Okay, so it's the same thing for sine inverse of x. It's not the same as 1 over sine of x. Okay, so you don't want to make that mistake. Okay, and what else am I? Make sure I didn't miss anything. Ah, that's right. Okay, so also sine inverse of x is also called, well, I'll use also twice. It's sometimes called arcsine of x. So you'll see arc sine of x more than you'll see sine inverse of x. I believe they came up with that because too many people were confusing the inverse and the exponent -1. Okay, so let's say, for example, and actually solving it is a whole lot easier than coming up with everything. Let's say if you want to find the exact value. For let's say for problem A, arc sine of -1/2. Say for problem B, arc sine of square root of 3/2. And let's say for C, sine inverse of 2. Okay. Now for A, now we know that sine of pi over 6 equals -1/2. Well, it actually equals +1/2. And we also know that sine of pi over 6, well, negative pi over 6 equals -1/2. Now, the thing is, negative pi over 6 is actually in our interval. $0.06